Hey everyone, it's me, Ray Long, and this is another episode of Full Stack Distributed Systems. This weekend, I had an amazing time. I went over to Next Gen Games on Wilshire Boulevard out in the Hollywood/La Brea area out here in Los Angeles, and I gotta say I had a blast. It was my first ever Warhammer 40k tournament, and in the spirit of bringing hobby back, everyone there had a fully painted army. So I want to give a huge shout out to the Long War Network, to Next Level Painting, and to everyone who brought a next level army to the 40k casually competitive tournament. Fantastic job, well done to everyone. And I stayed for about 3 rounds. Well, exactly 3 rounds. And at the end of the third round, I started getting inspired. Obviously, I've been looking at rule books all day, watching people play, rolling the dice, moving the models. And I've always had in the back of my mind an idea that I wanted to create a war game, obviously. But it's never quite fallen into place. But I got inspired yesterday to start working on what I consider to maybe be a universal set of wargaming rules. Because really, if you think about it in its most abstract sense, we only really have a few operations that we want to perform in our war game. We want to compose a list of troops, right? We want to compose an army list. We want to deploy them. We want to activate them. We want to move them. We want to make them shoot. We want to make them use their abilities. We want them to defend. And that's really it, you know? And think about it. What if we had a few well-defined interfaces that could capture all those pieces of functionality and could be used by any war game that's on the market right now? Because every war game has a similar set of problems. We have to calculate distance between objects using whatever unit of measurement the war game uses. Maybe it uses inches, maybe it uses millimeters. Doesn't matter. A Universal Wargame Engine should be able to handle any arbitrary unit of measurement. We should be able to store information about troops, their resource costs. Maybe that resource is called points. You know, in some games you buy units through points. Well, basically every game. You know, and we'll go on and we'll keep describing these different parts of our system, and we'll find that as we create them, as we begin to describe them in more and more detail, we're actually building them piece by piece into a fully functional working system that we can use both in our games client side and in our games server side. And that's the key to what I'm calling next level engineering. When we have an idea, we want to be able to take it from running on our local machine to a piece of software that can support millions of users who, well, frankly, are nowhere near our physical machine. So as an exercise, we're going to start working in this video on prototyping some game objects and some C# code. We're going to be thinking about the architecture of our game engine, and we're going to start thinking about how that's going to scale out into the web. And we'll see how far we can get in today's video, and we're going to keep building it on from here. Before we get into it, though, we do got to talk about the business side of the show. Obviously, the patrons are seeing this video first on patreon.com/officialraylong. A huge, gigantic thank you from the bottom of my heart to everyone that's supporting me on Patreon. If you aren't today, or even if you hear this later, or even if you see this video on YouTube, honestly, at the end of the day, I'm just happy that you're watching the video. And I hope that it's bringing you some actual real value to your hobby and to your career. And if that's the case, then feel free to give me a subscribe or a thumbs up, or visit on Patreon, or enroll over at the School on Teachable. That's full stack distributed systems.teachable.com. And I'll try to I'll definitely get a vanity URL to shorten that up in the future. But for now, full stack distributed systems.teachable.com. So that's it. That's all the plugs we need for the business side. Let's get into it. Okay, the first thing we have here is our Unity engine. Right now, I haven't upgraded to the newest 2018 release, but Unity 5.6.0 F3. I think that's the free version if I'm not mistaken. Um, it's modern enough for our needs. We're not going to be doing anything too fancy. We're basically going to be using pretty much some pretty vanilla-looking C# code as far as the Unity world is concerned. So let's go ahead and create our project. Well, I got a noise-canceling mic, but I can't cancel out fucking traffic. Excuse my wonderful fuck bombs there. I'm a carpet bombing, bomb dropping, F-bomb laying motherfucker. We may have exceeded our fuck quota for the show, people, but what are you gonna do? Alright, let's go take a look. Unity. Oh, you're taking so long, aren't you? Unity is taking its sweet time loading up here, ladies and gentlemen. You know, what are you gonna do? What are you gonna do? Now let's talk about what we're gonna be doing here. You may have seen that I've switched over to this screen over here. I prefer to use the bash shell that comes with the GitHub or the Git client on Windows. It accesses your file system in a way familiar to Unix systems. It is a Unix-like shell, so we're going to be using forward slashes. We don't need to put a drive letter or anything else like that. It maps everything correctly. I think it uses SIGWID under the hood or something like that. Doesn't really matter at the end of the day because, you know, it's all good. No, we don't want to do .NET. We want to go into our distributed. Now, where in the hell am I? I can't believe. Well, we'll get back to that in a minute. Anyway, we're going to go set up Git, but it looks like Unity's coming on up, so let's go take a peek. Alright, so this is pretty standard. We have basically our empty Unity game screen here. Okay, Unity editor is up to date. That's good. Good, very good. Let's go ahead and turn close services for now. We have our inspector. We have our main camera, our directional light. We can put this onto 2D view for now. Our console, our assets. Alright. My internet connection is just fine, thank you. Unity can be a little quirky. So here we have our blank assets folder. Now it's very important that we naming is really half the battle in programming, okay? It's very important to name things as clearly as possible. It's okay if you have a few extra words in there, you know. A long cryptic name usually betrays a long cryptic function or method that is probably a good candidate for refactoring, but sometimes extra precision is really what you need, so it all just depends. Take it case by case. So by now, some sorts of best practices have emerged in terms of organizing Unity projects. I have a way that I like to organize mine. Seems to be a good middle ground for all the different styles that I've seen out there. It's pretty straightforward. Okay. We have assets. We have untitled up here. So, in the spirit of naming things correctly, why don't we start with we're going to save the scene as something, but what are we going to save it as? Good question. Let's create a folder in here. We're going to call this Universal Wargame Engine. Okay, very good. We're going to go in here and we're going to create a folder. We're going to call this beast here scripts. There we go. And we're going to start thinking about how we want to organize our wonderful, wonderful project hierarchy. Well, we know we're probably going to end up using at least a couple of third-party assets in order to test out some of the functionality. I mean, really, we could use just simple cubes and spheres and primitives right from inside of Unity, but it might be interesting to take a look at maybe grabbing some of the free assets out of the store and maybe bolting them into our project, you know? Now, in the spirit of good programming practice, you should know that if you're not familiar with Unity, it has excuse me, sorry about that, ladies and gentlemen. If you're new to Unity, you may not know that Unity has an amazing asset store. Okay? You'll definitely want to check that out. There's a lot of free assets in there, and there are a lot of paid assets in there. And it's very important that you avoid the temptation to reinvent everything yourself all the time. Okay? Especially if there is no clear advantage to you doing so. You know, building a project is not just about writing clean code. That is very important, obviously. It's also important to get to market quickly with the right solution to the problem that you're trying to solve. In this case, we want to create a Universal Wargaming Engine. And I can't think of much more of an ambitious project for us to tackle as a couple of adventurous would-be Unity wizard level hackers. Okay. So we'll put our scripts in here. And you know, we can always rearrange things a little bit later. It's not a big deal. And inside of our scripts, this is where our actual programming code is going to live. And I like to break things up not by layers, but by concerns, right? In older architectures, you might see a folder called models, another one called services, another one called, you know, controllers and stuff like that. And I think that kind of layered architecture can be good. But I've also found that, like, if I were to put in here, let's say, turns, or initiative, or combat, or movement as the folders as top level concerns, then it's a lot easier to kind of understand what's going on under the hood, or at least we can hopefully be assured that we've been disciplined enough to keep our concerns within their proper domain, right? So let's create our first concern here, or our first package, or our first folder, or whatever you want to call it. Unity likes to call it folders. All right, let's see. Movement's pretty important. But what could be interesting is, what if we have our dice package first? Okay. We say, oh, well, we're going to need some dice in here. What are we going to need? We're going to need an eye roller. Or how about let's call it an interface. We'll call it an eye dice roller. Now in C#, the convention is to use I as the prefix for your interfaces. And since we want to be good citizens of the .NET universe, right, the .NET ecosystem, we'll go ahead and we'll model the same. But we'll keep our syntax highlighting in the way familiar to Unity. So we're going to load this up in Visual Studio. I happen to have Visual Studio in here, the 2017 Community Edition. So that's going to load up. Yeah, let's see. Yeah. While we're looking at this, we can see that Unity has generated a little bit of code for us. Now, here's what's interesting. By default, this stubbed out method is basically for creating an empty game object, or a basic game object that inherits from mono behavior. That's where you see public class iDice roller mono behavior. But we need an interface for our purposes, so we're going to get rid of the class. We're going to rename it interface, and we're not going to inherit from mono behavior because that would be incorrect. So just give me one moment here. Visual Studio is a bit hungry, so we're almost done loading it up. I'll be honest with you, I thought Mono Edit was going to load, so I was not quite prepared. But hey, you know what? We're all doing this together here, so what are you gonna do? What are you gonna do? You know? All right. So yeah, it's still loading. So we're just about done. Okay. Oh, good. It's loading up the theme now. How wonderful. How absolutely wonderful. Okay. And let's see. Now, normally in the game object, we have two main methods that we're concerned about, or concerned with rather. Those are the start and update methods. Start is exactly what it sounds like. It's called once to start the life cycle of the game object. You know, it's like turning over the ignition in your car or flipping the switch on your light, wall mounted light switch, you know. An update gets called once every game cycle or once every game loop. So basically, the way the game runs is there's basically an infinite loop that runs, and there are a series of steps where all of the behaviors and all the actions and all the state is resolved, and that starts again. You know, every time you press a button, like hit something on the joystick or hit a button or press a key or jump or even just sit there and let it tick, the game is moving. The game is doing things under the hood. Things are being, you know, state is state is being tracked, memory is being moved around, things are being allocated, all sorts of wonderful stuff is going on behind the scenes, and makes programming fascinating. Okay, here we go. Loading up Visual Studio. Now, Visual Studio can be a little finicky with Unity. Excuse me, ladies and gentlemen. Sorry about that siren. This is downtown LA. This is so crazy. That's alright. So, ladies and gentlemen, I am vacating the Wizard Tower soon and getting out of this madness and going for quieter realms. Alright, we see that Visual Studio is loaded up. Our wonderful, wonderful Unity 3D project. You can see that I'm using the regular blue theme. That's fine for now. We'll give it a little bit of brightness. Okay. So let's make this, let's start off right away. So we're going to make this an interface. Okay. And this should tell me that, it should give me a couple of errors. We're not going to be able to inherit from mono behavior, and interfaces don't have bodies. They only have declarations, right? And okay, so now this is a valid interface. Now what's interesting is we can make some decisions about whether or not we want to include these in here, but the game state is not our concern, okay? Don't be tempted to keep this in here just because you think you're going to need it. You're not going to fucking need it. Excuse my language. I'm just passionate about this, alright? Just start off with a blank slate. And now let's think about what we're going to need in our dice roller. Well, we're probably going to need to know um, how many sides are on our dice, right? And how do we want to describe that? We could call it number of sides for now. Uh, of course, our interface can't contain a field, so we need to make a method. Number of sides. But we don't want a method. No, 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 no. What we really want is a property. Now, what's going to be tricky is, the backing field is an implementation detail that is going to be the responsibility of whatever implements the iDice roller interface. Okay? But here's where it gets a little tricky. In the Unity editor, you can expose public members of the class in the editor to modify them. It's very handy. But it accepts fields, not properties. So if we want to be able to, we'll get into this more as we build out the feature in the editor, but we're going to have to do a little bit of extra work in order to make this a little more friendly for, let's say, somebody prototyping a game with our game engine, or somebody actually building or doing the level design, or doing animations and they want to hook into some of the events in our system, or whatever. We want to make this as user friendly to consume as possible. So okay, we're going to need a number of sides. We're going to need a number of dice. Right? We're going to need a target value. Typically we want to meet or exceed the target value, right? And we can say, actually, let's do this. And reroll values. So this will say, give us an array of integers, and if we happen to have one of those in our result, then we're going to go ahead and reroll those as we build up the logic, right? So reroll values, and let's create a method that returns an integer, and we'll call it roll dice. So basically, as you can imagine, we're going to have a number of sides, a number of dice, a target value, number of rerolls, and a method to roll the dice. Sorry about the coughing, ladies and gentlemen. I got the Nurgles rot inside my lungs from all the allergies and all the pollution out here in fucking LA. Alright, we're going to notice that we don't need these using statements. The IDE is telling us so. Let's remove unnecessary usings. Let's go ahead and save our interface. And where does it live? Where does it live, right? Okay, so we want to make a package structure for our code in order to, or rather a namespace structure for our code, because we don't want anything that we create to override or conflict or clash with classes that may be defined in other people's and other publishers' code, right? So we want to make sure that doesn't happen. It's important to create a namespace for our code. We're going to call this full stack Distributed systems. Universal. Wow, you see why names are important? Dice. Dice. I'm over here with the game developers. I was over there with the comedians. I'm over here now. Alright, enough bad dice. So now we have a namespace. Okay. And now we want to decide if we want to have a game object attached to our interface. Is that useful? Well, if we attach a game object now, the problem is it's going to be harder to write unit tests around our code. Way harder. Way harder than it ought to be. So, by keeping it like this, yeah, we have a little verbosity. We're a bit verbose with our name stack, or with our name stack, with our namespace. I think that's okay for now. Okay. Well, this build, that's an interesting question. Let's see. Let's see if Visual Studio will build our Universal Wargame Engine as it stands right now. Yeah. So we'll see here our typical life cycle in terms of building our code. We'll write some code. Maybe we'll try to see if the compiler likes it. It should, right? I mean, we don't have any errors. We don't see any bugs called out by the IDE or the Integrated Development Environment on the screen. So, I mean, syntactically everything seems correct. Is it logically correct? Does it actually solve the problem? The compiler's not going to be able to tell us that. We need to be able to inspect the code ourselves and find that out for ourselves. But so far our code is building, and that's just fine. Now, here's where it gets interesting. We have a dice roller. We can start to think about how we want this dice roller to be used inside of our system. Now, if we're good at keeping our components reasonably decoupled, we're going to want to pass around the dice roller interface. We're probably also going to want to pass around, or not necessarily pass around, that's the wrong language to use. Please do not fret, my functional programming friends. I'm not talking about introducing unwanted side effects. We're going to write functions and methods that tend to try to accept interfaces wherever possible in order to keep the code relatively loosely coupled, right? Meaning, if I change the dice roller, I shouldn't necessarily have to break and then go fix something else like the movement subsystem or the, the army roster manager or whatever we want to call it. So changing one thing here shouldn't negatively affect everything else everywhere else. Okay. So if we go ahead and head back over to Unity, we'll see that Unity is aware that our code has changed here. And something that we can do, we can enable, I'm going to hit the collab button up here in Unity. And I want to enable collab probably on this. That way I'm going to be able to push this up to the cloud and I'm not going to have to worry about using Git. So we'll call this initial commit. And we'll publish this to as a private project here to our Unity Cloud account. There we go, initial commit, up to date. Okay, so now we probably need to implement a dice roller. So why don't we go ahead and create a dice roller. Okay. Part of the annoying thing with Visual Studio, we're going to flip back over, is sometimes we have to. Oh, I got a plane up there. So sometimes when we go ahead and switch back over to Visual Studio, if the files have changed on disk, which they're likely to do because Unity touches things all the time, then it's going to keep asking us to reload our solution. And I just go ahead and allow it. It doesn't seem to happen with Mono Edit, but I like Visual Studio better, so I can live with it. Alright, so we have our mono behavior, which is good. This means we're going to be able to create a game object we want. But we also want to have our dice roller interface as well. We don't know how to find it yet, right? So maybe what we should do is we should put this in its own namespace. Oh look, Visual Studio knows what we need to do. Imagine that. It's a very intelligent integrated development environment. My favorite. Okay, so now let's go ahead and also implement our dice roller. Fantastic. And now we don't have any of these members implemented. Visual Studio will let us know, and we can implement the interface. Look at that. Fantastic. We don't want necessarily what it has here, but you know, see how we're using the like well, we're using the expression getters and setters, and I wonder if, well, we're gonna have to upgrade the newest Unity sometime because it has better .NET support, which has newer language features like all the C# 6.0, I think, and 7.0, whatever the language is up to now, features. Traditionally, .NET, or excuse me, Unity has been plagued by being stuck on .NET 3.5, I think, and it's made things in the past a bit difficult, as you can imagine. .NET keeps evolving far past the 3.5 ecosystem, and a lot of Unity developers haven't been able to necessarily keep up the pace. So anyway, when we start, we should probably let everyone know that we're alive, right? So why don't we go to logger dot. Okay, let's see. Here we go. Debug.log. Okay, so we're going to send a message to the log. We're going to say starting the dice roller. Okay. And why don't we take this? There's no need for you to format the selection. How about you just give me... Alright, so now we know that Visual Studio is going to be slow whenever I try to copy and paste anything. So that's great. So... Okay. So, why don't we do this now? We'll call these the is it region? Private fields. Now we can collapse the code using our regions. So we're going to do public int. You can see where this is going. We should always want to avoid null. Let's just put it that way. Dice. You can see where this is going. Target. See public. This will be interesting to see how this rolls. How this goes. You may be wondering. Well, it turns out the Unity editor is very intelligent. Okay. Why don't we call this region public properties. Return number of sides. Let's do private set for now. Come on. Why did I mess this up? Because I am not good. So get should be. Now what in tarnation? Is C# being weird on me? We should be able to use the following format to have a getter and a setter. Alright. I mean, obviously, this needs to be here. Why is it? It's all funky. Let's just get it to work and then we can make it pretty. This, really? Boy. I wonder if we could actually... That'd be way too easy, wouldn't it? Come on. Oh. Come on. The namespace, what? minutes. See that? Oftentimes bugs are just a simple typo away from being solved. As you can tell, I might be getting a little bit late over here. So we'll do number of dice. So we won't have to do this after we update our Unity, but I was not about to update our my Unity installation right before doing this video. That would be foolish. So we got number of dice. Why do we want to do this? Well, that's a good question. Maybe we don't. It seems that the Unity community favors, well, fields instead of properties. So I have to think maybe writing all this code is a waste of time. And maybe, just maybe, the community knows something that maybe I don't know and I should pay attention to. Okay? So we're just going to call this fields. We're going to get rid of this and this. We're going to go to this declaration, or go to the definition, F12, and we're going to get rid of these. And now we can say iDiceRoller is an interface with one method in its contract, and that is to roll the dice. And you don't have to worry about how the dice roller is configured. That's an implementation detail. This means that anybody can call roll dice if they have a pointer to or a reference to an object that implements this interface. So that makes our code super easy. Like I said, we can get rid of all the nonsense. And we can simply do this. Debug.log. Rolling the dice. Number of sides equals. So here's what kind of sucks about the Unity logger. Maybe we'll try to make a better method. Number of sides. Right. This is basically like almost like a Java style two-string method. So, what are you gonna do? You know, I want this in the logger. This is a pain in the ass to write now, right now, but it'll be totally worth it. I think I want the reroll values here, and the target value be last, just for easy processing by the eyes, you know. Target value equals target value. We got a couple of errors on our source file here, looks like. Let's go figure them out, see what we can do. Oh, of course. So, how can we do? We need to make an array. See, in Kotlin, I could just type array of. It'd be nice to bring that over to .NET. Let's see. I'm actually going to go Google C# array literal. How do you do it? I forgot. When you know so many languages, you tend to forget a lot about all of them. Oh, yes. We do int, and then we could do this, and then do this, right? Can I just do this? I guess I can just do that. And now this has to return something, so we'll return 0 for now. And now we have the beginning of our dice roller implementation. Let's go ahead and see if this builds. Okay. So we're going to go ahead and hop back over into Unity. And now we're going to get real crazy here. Let's go back into Universal Wargame Engine. Let's create a new folder. We're going to call it Scenes. We're going to create an empty game object. We're going to call this Dice Roller. Okay. We're going to add a Dice Roller script to it. And now, just make sure, yep. Now we can see the number of sides, the number of dice, target value, reroll values. You'll see that it thinks we have an array here with one element whose element only value is 0. If I were to sneak back over to Visual Studio, change the definition of the class so that it had a default value of 1, and Unity got a chance to recompile everything, well, it would change if I made a new game object, right? So we can go ahead and remove this component, add it again, and now we can see it defaults to 1. But we don't want it to default to 1. We want it to default to 0. So let's go ahead and remove the component. Sneak back over to Visual Studio. Off camera, do some magic. Hop back over here like a wizard. Add the dice roller. Very good. Alright. Now we're going to save this in here. Call it Scenes. Let's call this, here's what I want to do. I want to call it, Workshop 001. That's just the way I like to name my workbench scenes. Either workshop or workbench or something along those lines. I like to prefix it with an underscore, so that way in the file search on Windows and most file systems it'll shoot right to the top. I'm lazy, I don't like sorting stuff. So let's go ahead and let's see. Go ahead and run this and see what happens. We're hitting run in Unity. We haven't done this yet in the video. We're going to see if our game object does anything. And we can see that this just keeps ticking up. We're not going to collapse. And we can see that this game object is just chugging along. Like I said, every game loop, it is updating the dice roller. There we go. Isn't this fantastic? So we have, we'll call this a whip. First iteration of the dice roller game object. Go ahead and publish this to the cloud. Now, if we keep our project to just code for now, we're going to keep the file size footprint to be very small. Right now it's just 9.5 kilobytes. You know, I think sneezing is more data intensive than that, so it'll be fine. You start adding 3D graphics, meshes, textures, other stuff like that, it's definitely going to get to be a heavy project. So, if you are strictly a developer and you want your game packages to be nice and light, try to keep them mostly to just code, just scripts and shaders and like some placeholder prefabs that either have very minimal art or just use the built-in 2D assets, or 3D if you must. But try to be a bit conservative in what you package with your bundle. That way, people can download it quickly, use it quickly, and get it updated quickly. We don't want to inconvenience our developers any more than we have to. Developing is already inconvenient enough. Alright, so just a brief recap. Let's go over what we've done so far in this hour. The hour has flown by, and we've actually covered quite a bit. We've talked about a lot of things, even though we only appear to have a little bit of code that we've actually written for real. Okay? So in Unity, we started off with a project, and we talked about how we were going to organize our assets. At the top level, we have Universal Wargame Engine. Inside we have scenes and scripts. Inside of our scripts we have dice. Dice! We have our dice roller and our iDice roller. Our iDice roller is the interface. And if we're going to be, if we want to write really clean code, other components that need a dice roller, if they can, they should prefer the interface as the what they accept in their, as a parameter. That way, you can always make sure you get a real dice roller. If you just accept a generic game object, then any old person can shove any old game object into any old thing they want, and it'll just probably crash. Because you're going to be trying to call things in that game object that do not exist, right? So, try to prefer talking to interfaces as much as you can. Keep those separations of concerns. So we did that. We wrote the interface. Let's hop back over to Visual Studio real quick. And we'll see that we have a nice clean interface here. We don't have any, we're not importing anything from any other namespaces. We have our code in a namespace. We have a public interface called iDice Roller. It has one method in its contract, a method called roll dice that accepts no parameters and returns a single integer. We made our first implementation of dice roller. We were going to add a bunch of properties, but we said, hey, you know what? The community at large has determined in Unity that public fields are the way to go. This might not sit well with traditional object-oriented programmers, but this is a whole different problem domain, okay? I agree with you. Not having getters and setters feels weird. We can put them in if we want to, but the community has determined that for our use cases, we probably really don't need them. This is actually one of the domains where you actually want tightly controlled side effects. So, depending on how you architect things. So, again, we want our architecture to be clean. We want our code to be clean. When we come back and look at this later, we don't want to be lost. We don't want the people maintaining our code to be lost, right? So that's it for now. This is the first video of our Universal Wargame Engine. We're going to go ahead and get this up on Patreon for the patrons. And then a week from today, or 2 weeks, or whatever we have up on there, I believe we currently have a 1 week release cadence. I should know, I set it up, but I'll double check. Way to be prepared. So anyway, we'll get our release cadence set up, and then we'll go ahead and get this out like a week later on YouTube for everyone at large. So thanks again for checking us out. You can get us at patreon.com/officialraylog or facebook.com/fullstackdistributedsystems. And you can look at our online teachable.com courses at full-stack-distributed-systems.teachable.com. Thank you for your time. I hope you had fun learning, and I can't wait to do the next video. Bye for now.